Hey Logan. All right, here we go. So 5-9, powers of products and quotients. So go ahead and make sure you have your notebook out and go ahead and record this as 5-9, powers of products and quotients. Okay. At some points in this video, I will ask you to pause and work some problems on your own. So make sure you're ready to do that. And here we go. So the idea behind what we're doing here, okay, so powers, so we're talking about exponents, and then products and quotients. So products meaning multiplication problems, quotients meaning division problems. So here's an example of a power of a product. We've got two things being multiplied together here. So we've got 4 and 2, and they're being raised to the third power. Now I know you could actually evaluate this. You would do 4 times 2, which is 8 to the third power, so 8 times 8 times 8, and you'd come up with your answer. But let's think this through just a little differently here. So to the third power means that we're going to multiply everything that's in the parentheses by itself 3 times. So it's going to be 4 times 3, 2, or I'm sorry, 4 times 2 times 4 times 2 times 4 times 2. And so then if I look at that, well, actually, things in parentheses are being multiplied, things with a dot between them are being multiplied. It's all multiplication. So I'm just going to use the same symbol for everything. So 4 times 2, 4 times 2, 4 times 2. Remember that in multiplication, we can use the commutative property, which means we can move them around whichever way we would like to. And we're still going to get the same answer. And so I'm going to rearrange them so all the 4s are together and all the 2s are together. Well, when I do that, you realize, oh, I've got 4 times 4 times 4, which is essentially 4 to the third power. And I've got 2 times 2 times 2, which is 2 to the third power. So 4 times 2 to the third power is the same thing as 4 to the third times 2 to the third. I'll get the same answer either way. And this is where we come up with our power of a product rule. So make sure you write this down. So the power of a product rule means that anytime I have two things being multiplied together raised to the same power, I can pretty much distribute that power throughout that parenthesis. It's the same as, a to the m and b to the m. Okay? All right, so let's give this a go. See if I can scroll down to the next one here. Yay! Aha. All right, so here's an example of how we can use this here. So you have simplify 4 times x squared all to the third power. Simplifying meaning that we're going to try to evaluate as much as we can. Well, our product of a power rule says that I can rewrite this as 4 to the third times x squared to the third. All right, and then I can evaluate from there. So 4 to the third, so it would be 4 times 4 times 4. So that would be 4 times 4 is 16 times 4 is 64. All right, x squared to the third. Well, if I think about that, that would be x squared times x squared times x squared. And each of these x squareds is 2 x's being multiplied together, right? Okay, so that would mean that it's basically 6 x's being multiplied together. So this would be x to the 6th. That's also 2 times 3, you might notice. So you might remember that whole power to a power rule, that you can multiply those powers together. So 64 x to the 6th is my simplified answer. All right. So now is when I would like you to pause the video and you try this yourself, okay? So try simplifying 2p to the 4th power and xy squared to the 5th power. So go ahead and pause. All right, so here's your answers you should have come up with. All right, if you're not sure how I got those, now would be a good time to ask your mom if you can FaceTime me, and I would be happy to explain. Okay. All right, so assuming that went well, let's go ahead and talk about a couple interesting examples. So this time I have two things that look very similar to each other, but they are actually a little bit different. So when you look at these, I have negative 5x squared and I have negative 5x squared. The only difference is where the negative is, but it makes a big difference because in this case over here, the negative is inside the parenthesis, which means it's all part of what's being squared. So squared means multiplied by itself, right? So this is negative 5x times negative 5x. Okay, so a negative times a negative is positive, and then 5 times 5 is 25, and then x times x is x squared. Okay, so if we think of this from the product of the powers rule, that means that that squared basically got put into the negative as well. It was negative 5 squared, and so that's where we came up with a positive 25. Okay, over here the negative is outside the parentheses, so the only thing being multiplied by itself is 5x times 5x. Okay, so that's giving you 25x squared, but I haven't dealt with the negative yet. The negative is still out in front. So this one, the answer is negative 25x squared. So just be very careful, okay, about where the parentheses, or yeah, where the negative is in the parentheses, because it makes a big difference. Okay. All right, the last thing we need to talk about is what happens when there's a division problem. What about a product of, or I'm sorry, a power of quotients? Okay, so here I have 4 over 5 to the third, and we know that that's the same as, well, to the third power means multiplied by itself 3 times, so 4 over 5 times 4 over 5 times 4 over 5. Well, when I multiply fractions together, I multiply across the top, so that's 4 times 4 times 4, and then when I multiply across the bottom, so 5 times 5 times 5. So this would be the same as 4 to the third over 5 to the third. So you'll see that quotients work very similarly to products in that that power pretty much gets distributed throughout the parenthesis. So a over b to the m is the same as a to the m over b to the m. So here's an example of where that could come into play. So let's say I wanted you to find the area of this square tile, and we can see that the length of each side is 3 over b for some reason. Okay, and so if I'm looking to find area, well, area is length times width, and in the case of a square, length and width are the same, and so the area is basically the length of the side squared. So in this case, that would be 3 over b squared, which would be 3 squared over b squared. Yeah. And I can evaluate 3 squared. 3 squared would be 9. So 9 over b squared is going to be the area of this tile. Okay. All right, so again, if you have any questions, definitely get in contact with me. Otherwise, your homework is posted on our website, and enjoy.